Jai Hind everyone, my name is Aman Gupta and I am working as an assistant professor in MC department in Akgec Engineering College. My subject is software engineering whose subject code is BMC 302. Today my topic is software development life cycle, that is SDLC. So what is SDLC? What is software actually? It is first of all it is a list of instructions that has been set of instructions that has been given to perform a task, that is a program, and with the combination of some program, some documentation, some data, it is a software is developed. And the process through which a software is developed, we need a process. So this is the process, this is the life cycle through which a software has been developed. And this software development life cycle is used to facilitate the development of large software products in terms of to develop a very well defined, systematic and cost effective way. So information system goes through a series of phases from conception to implementation, that is from 0 to the last 4 or 5 steps. There are some 5 to 6 phases that a software has to be followed, and according to that it has been developed. So this process is called the software development life cycle. So various reasons for using a life cycle model. We have different models available to accomplish this task. So it is important to, it helps to understand the entire process. If we work according to some model, then we have a systematic way that first we have to work on that phase, then on the next phase we have to work on that terms, we have to design, we have to code, we have to implement. So these are some phases that through which a software is gone through. So it enforces a structured approach to the development. So it enables planning of resources in advance. If we know that we have to follow this type of approach, so and we have these type of resources, so we can plan accordingly, and it also enables subsequent controls of them, and it aids management to track the progress of the system. So software development life cycle have all the activities from initial analysis until the end of the work. So we have different type of phases which include the entire process for the software development. So formal process for software development is describe phases of development process. We have some development phases which we are going to discuss later, and then they gives guidelines for how to carry out the phases, that what type of work we have to do in that phase and this phase. This is the development phases. So these are some phases in which a developer have to work if he is work according to some SDLC model. The first phase is the requirement gathering and the analysis. Actually, first phase is the feasibility study, that a user, this comes under the requirement gathering, that first developer needs to check that this software is possible or not, the development of the software is possible or not. So, and then the phase is requirement gathering, that all the requirements have been gathered from different resources and analysis has been done on that. Data has been collected and analysis has been done on that data. Next part is the design part, and then the implementation, coding part, and then we have testing on all the components, and then we have the maintenance part. So what is a software process? So at a set of activities, actions, tasks, work products that are required to engineer high quality software. So these are all required to develop a software. So these are some generic activities which are important for all the software process. First of all, specification. Specification means what the system should do and what are the constraints that comes when a software is developed. Next is the development, the real-time production of the software system. Next one is the validation. In this we have checked that the software is developing according to the needs of the client or the end user. Next one is the evolution, that it can be changed according to the demands of the end user. So we have certain type of models available according to the software process model. First one is the waterfall model, prototype model, spiral model, iterative enhancement model, rapid application development model. So these are some example of software process models. First of all, we talk about the waterfall model. So this is the most common and classical life cycle model, and it is also referred to as a linear sequential model because it works like a waterfall or in a linear sequential manner. So these are some phases, and it works that if this phase has been done, working on that phase is done, then we comes on this phase, then we come on this phase, then we come on this phase, and then we have some software. So if we come from this phase to this phase, then we never will go through the first phase. So this is that's why it is called the linear sequential life cycle model. So it is very simple to understand that in each phase must be completed in its entirely. Means because it is not possible that if we are working on that phase, so we can go to this phase. So first of all, we have to complete this, then we have to complete this, then this, and then we complete this. So the least flexible and most obsolete of the life cycle model. That's why we called it most least flexible model in all the comparative to other models. So well suited to projects that has low risk in the areas of user interface, in which if we have some user requirements that are freezed, that need to be changed according to the time, then it is the well suited to that type of project. And but high risk in budget and schedule predictably there and control. So these are the some phases under the waterfall model. First of all, the requirement analysis and specification, in which all the data has been gathered and SRS has been prepared on the data that has been gathered from different type of resources, from database, means social media handles. According to the customer need, the data is developed or gathered, and analysis has been done on that data. According to that data requirement, a design has been developed. Means the classes has been developed, designed actually, and the classes, interfaces, and data flow diagram, these all has been designed in this phase. Next one is the coding and the unit testing. Coding part. Now in the coding part, all the classes, interfaces that has been designed in the design phase, then it has been implemented in the coding phase. The code has been written in this phase, and on the basis of the component of a software product, a unit testing has been done on the different components. Now next is the integration and system testing. Means we test our software that it has been working fine, all the components have been merged, and then it has been tested that it is working properly. Now next part is the maintenance, that the software that has been developed is working fine, then it is in the maintenance phase. Now first step is the requirement analysis and specification. So decide what the project is supposed to do. Means feasibility study, that what is the flow of the software. It has been decided in this phase, and do not think about the program will accomplish task. It describes what the program will do once completed. So it should have it is having a user manual which tells that how the user will operate the program. It have all the steps that how the software can work. Now, and the performance criteria has been described in this document. Planning for quality assurance requirement and identification of risk associated with the project is also done at this stage, and the output of this stage is the software requirement specification document, that is called as the SRS document. And this document works as a contract between the customer and the developer, because before developing any type of software, it is very important that at some point the requirements are freezed, then only we can start working on some software. So this is the contract, that these are the requirements, and this is the final product that we need according to the client, and the developer is also satisfied that within that time duration I will be able to deliver that software. Now next part is design. In this phase it plans how to implement the system, discover structures that underlie the problem to be solved, decide what classes and methods do you need, classes designs, interfaces design, DFDs designs, ERD designs. So all that type of design has been done under this phase, and the output of that in this phase output is software design document, and this phase is needed to start the next phase, that is the coding or implementation phase. Next is the implementation and unit testing. In this we give body to the classes that we designed in the design phase, and in this we write and compile the code. Implementation of design begins concerning the writing code, and code implements means given body to the classes and methods that has been designed in the design phase, and the output in this phase that we have found is code listing and unit testing reports. The small modules are tested in isolation from the rest of the software product after writing some overhead code. Next phase is the integration and system testing. It is very important part of our software life cycle. Effective testing results in the delivery of high quality software, satisfied users, low maintenance cost, and more accurate and reliable results. So unit testing checks whether each independent module is working fine, and very less chance to determine whether the interface between modules is also correct or not. So these components are checked independently that these components are working fine. Hence integration testing is done. After unit testing is done, it has been checked that after integration it has been working fine or not. So system testing tests the entire system and software is a part of it. So builds confidence in developers. Test cases and test reports, different type of test cases. The system, the software has been checked with the help of different type of test cases. Different type of values, input values has been given to the software, and it has been checked that the desired result has been provided, get it or not. Last part of this is maintenance, in which the user install the program and user use the program for its intended purpose. So software maintenance includes error correction in the terms of error correction, enhancement of capabilities, deletion of obsolete capabilities, and optimization of the code. Output revised version and reports. The output of that phase is revised version, maybe the version may be improved or the reports. Now, what are the advantages of waterfall model? It is as we already said that it is a linear model, it is a segmental model, it is a systematic and sequential, simple one, and with proper documentation. Now, there are some disadvantages that it is difficult to define all the requirement at the beginning of the project, because in this waterfall model, we have to freeze all the requirement in the starting when the product is a start to develop. So, maybe it is very difficult that all the requirement has been available with the developer at the time of the starting of the software. So, model is not suitable for accommodating any change. If we are going from one phase to another, then we cannot change the changes in our previous phase. It does not scale up well to the large project. Inflexible partitioning of the project into distinct stages, and it makes it difficult to respond to changing customer requirements. So, this model is only appropriate when the requirements are well understood and well defined at the time of beginning, of construction of a software, and changes will be fairly limited because during the design process. So, few business systems have a stable requirement, then maybe the waterfall model works fine. Waterfall model is mostly used for large systems engineering project where a system is developed at several sites. In this, we have an iterative waterfall model. To improvise the waterfall model, we have a model, iterative waterfall model. It assumes in its design that no error will occur during the design phase. It introduces feedback paths to the previous phases of each process phase. As we know that in waterfall model, we cannot go to the previous phase, but in iterative waterfall model, we the next phase give feedback to the previous phase and it can be changed accordingly. It is still preferred to detect the errors in the same phase they occur. So, conduct reviews after each milestone. This is the iterative waterfall model, that after going from feasibility study to requirement analysis, then design, coding, testing, maintenance. These are all parts of waterfall model, but the difference between waterfall and iterative waterfall model is that this phase can give suggestions to this and this. So, after that it can be improvised. So, in this model, the whole requirement is divided into various builds. So, each module passes through the requirement, design, implementation and testing phases, and this is a method of software development when the product is designed, implemented and tested incrementally until the product is finished. So, it is called the iterative enhancement model, and in this model the software is broken down into several modules which are incrementally developed and delivered. So, first the development team develops the core module of system, then it is later refined into increasing levels of capability of adding new functionalities in the successive versions. So, each subsequent release of module adds functionality to the previous version of the software, and this process always continues till the complete system or the required result has been achieved. This is the increment enhancement model, that analysis, system design, coding, testing, and then we get the first deliverable, first product. And on the basis of that, if we have some feedback and improvements, then next version has been starts working on the other version of the program. That it means that in this we have some additional functionality, and this we have some another functionality. Now, the feedback from early increments improve the later stages, and the possibility of changes in requirement is reduced because shorter time is spent between design of component and its delivery. So, user can have benefit earlier than with a conventional approach. Smaller sub-projects are easier to control and manage, as we know that if a big problem, complex problem divided into small parts, it is easy to handle. The project can be temporarily abandoned if more urgent work crops up, and job satisfaction is increased for developers because they will see a developed product at regular short intervals. There may be some disadvantages that programmers may be more productive working on a large system than on series of smaller ones. Maybe there may be some problems to divide into functional units and software breakage. That is the maybe it may require some modifications to the earlier increments. Next one is the rapid application development model. It is proposed when requirement and solutions can be modularized as independent system, each of which can be developed by different teams. So, user involvement is essential from the requirement phase to the delivery of the product. So, process is started with a rapid prototype and is given to the user for evolution. Actually, our prototype has been developed before actual starting of the software. So, user feedback is obtained and prototype is refined. When the user defined prototype has been ready, then only the working on the actual product has been started, and design documents are prepared with the association of the users. So, the development is distributed into component development team, and the team works in tandem, and total development is completed in a short period of time. So, the Martin approach to RAD include 4 phases. These 4 phases are required in Martin's approach: required planning, user design, construction and cutover. So, this is the model. Build a rapid prototype. First of all, build a prototype according to the user requirement or client needs. Give it to a user for evaluation and obtain feedback. Prototype is refined, and this can be achieved only with the active participation of the end user or the client. So, requirement planning, user description, construction and cutover. So, this is the requirement planning phase. User description phase, in which automated tools capture information from users. Construction phase, in which productivity tools has been used like code generator, skin generator, and last one is the cutover phase: installation of system, user accepting testing and user training. The strength of RAD is reduced cycle time, improved productivity, customer involvement throughout the complete cycle, minimizes the risk of not achieving customer satisfaction and business needs. It focuses moves from documentation to the code, and user modeling concept to capture the information about businesses, data and the processes. Some weakness of this type of model, that its accelerated development process must give quick responses to the user, risk of never achieving closure, and hard to use with legacy systems. It requires a system that can be modularized. Developers and customers must be committed to rapid fire activities in an abbreviated time frame. Now, when to use RAD? Reasonably well-known requirement. When we have reasonably requirements freezed, user involvement, project can be time boxed, functionality delivered, high performance not required, low technical risk, and system can be modularized. That's all for today. Thank you so much.